All right, last presentation for this week, we're going to talk a little about configuration control. This is something that we have talked about with scope management and with time management and with schedule management in terms of tracking what you've got and making sure you maintain some control over the plan and the expectations of the project going forward. We're going to talk about this, especially this week, because it ties to quality in a lot of different ways, and just maintaining your configuration management from a quality perspective for the project. But also, this is an important element of maintaining a lower risk posture, because if you have control and knowledge of what's going on, then your risk to the overall project would be a lot less. So configuration control, and we'll be developing a configuration control plan as part of the overall project management plan that you'll be doing this term. What you're doing with configuration control is identifying, prioritizing uncertainties, and driving change. Quality is the correct execution. Configuration control ties all that together with scope. So the three main areas that we've got listed here, risk management, quality, and scope, kind of tied together using the configuration control mechanisms and processes. There is a common practice called CMMI, where it basically just says that it gives you a formula for determining how much configuration management you've actually got. The CMMI is configuration management maturity levels. And basically, out of Carnegie Mellon, they developed this, and it lays out basically incomplete, performed, managed, defined, quantitatively managed, and optimized as 5 different levels. What they do is put expectations on each of those levels, and if a CMMI auditor comes in and looks at your processes and how they're executed, they basically tag you with one of these levels. So if you are incomplete, meaning you don't have any configuration control, you're level 0. If you're doing some processes, you're performed. If you've managed it, so there's actually processes in place to manage your CMMI levels and see where you're at and all that, you'll be level 2. If it's defined, meaning everything is laid out and defined as to where you fall, it's level 3. If you're quantitatively managing your processes, so if you're using the results of analysis of your configuration control to feed and improve, then you're at level 4. And basically, if you're doing that on a continual basis and actually seeing those optimizations, you're at level 5. 5 is hard to get to, but companies that aren't at least at CMMI level 3, for example, can't really bid on government contracts. So there is some layer of this that is accepted, and we need to be cognizant of what CMMI means to us. And look at those processes and those understanding of overall maturity to basically manage our change control. 3 main objectives of this are to influence the factors that create changes and ensure that those changes are beneficial, determine that changes occurred, and then managing those actual changes as they occur. So what we're trying to get at here is, remember we talked in the first week about verbal change controls. Users coming in and say, hey, can you add this onto this? Can you do this different? We want to make sure that we're tracking all changes, because all of those little changes can influence, number one, the schedule, but they can also influence and ripple back into the overall design. Changes that we may not think are innocuous can actually change what was expected in the overall requirements of the project. And again, those are things that anything that's outside of the acceptance criteria simply distracts from the project scope, which is to finish this thing at low risk, on time, and under budget. Baseline basically is the approved management plan with all the approved changes as it stands. This is what we're doing, and that can be a baseline for scope, it can be a baseline for software, it can be a baseline for cost, whatever the approved plan is. Configuration management basically ensures the descriptions of those products are complete. It involves identifying and controlling the design as we move forward for all those different areas, and creating those, basically the documentation, supporting documentation that'll define that. Your configuration management specialists are going to be the people that identify and document the configuration changes, control those changes, record and report them, and then audit the products to make sure that we're actually matching to what we said we were going to be conforming to in terms of the requirements. This has to be done in all the major areas. So like I said, scope, software, and in the execution phase, cost, and schedule all have to be under configuration management. How do you actually do that management? Well, you use a couple of elements here. Change control system is a formal documented process for work, how it can be changed, and who can change it, and those kinds of things. Describes how it can be authorized, and then who's going to actually make the changes themselves. That's your change control system. Okay. For software, a lot of times that comes in as a loaded executable system where you can actually lock down the software code, and then if you need to go in, it has to go through some user processes and they approve all that stuff. For other things like scope and schedule, it has to be a process that you've built in. Change Control Board, a CCB, is usually a set of people, a formal group of people responsible for approving or rejecting a change. So all the changes come up to them, they go through some guidelines and evaluate it and decide whether they're going to make the change or not. That change control process basically wraps that stuff together, both of those together. Some CCBs only meet occasionally. Some CCBs meet very frequently, depending on the activity of change, the level of change, and the kind of the impact of changes that are being requested of the process. So sometimes you have special policies in place for time-sensitive changes that can go in through the CCB, but everything has to be part of that overall change control process. Going back to when we talked about risk, remember, this is why we're doing this. Quality impact chart that we showed you earlier, the risks have the same effect when they're realized into issues that they need to be addressed. So the more we can track these changes and make sure that we understand the impact of a change as we go forward. If we've made a change and it's not controlled, then we don't know as we're developing through here that we're programming to something different than what we actually intended. That's going to wind up probably causing bugs. It's going to be a huge expense. So you control your changes, you understand what's going on. That way, when you go through the CCB, if a change comes up during unit testing or development, you can go back through the CCB and say, do we really need to do this? And if we don't touch anything, because it would drive us back to go do that unit testing again and some system level testing and some huge expense. That's why the CCB is in place. There are times when you have to, right? I mean, there's things that you found or good ideas that have come along that, if we look at it and say this really wouldn't cost that much and it would improve the acceptance criteria, then you can go ahead and do that. But make sure we're controlling it. It's all about managing risk. This is the most destructive attribute of large-scale IT projects, including data analytics projects, like what we're doing. Scope, time, and cost can be managed through margin allocation, right? So we're talking about using our management reserves to go ahead and work through scope, time, and cost issues. But risks kind of defy that planning. So we have a margin out there at 10%. We don't really know if that's going to cover what we can encounter. That's the problem with risk. The solution is burn down risks as early as possible from your design all the way through your configuration and then your development. And if your configuration isn't controlled, then you don't have a good picture of where your risks actually exist. And if you don't know where they are, then it's going to be really hard to manage them. Risks-based sequencing is one effort to do this. So we talk about shifting left. Anytime a risk is identified, you should religiously attempt to move its resolution as far to the left on the schedule as possible. Don't leave risks out there that are unaddressed and it's not known as to what's going to be the impact of them. Cost of any resulting issue is going to be less. Reason being, think about your schedule. If we move a risk resolution far to the left, what we're doing is getting back on that curve where we're identifying any changes early, right? And so the downstream cost of those changes is going to be a lot less. So anytime you identify a risk, try to shift it left as much as possible on the schedule. Time delay of any resulting issue is going to be less. The cost of the resulting issue is going to be less. The ability to work through scope changes that might be involved is going to be a lot easier if we're doing that up front, especially if we have the users involved. And your ability to get the best resources to fix the problem are going to be better too, because if the issue is being realized earlier on, then maybe everyone else who's really key to solving it isn't tied up in all their other projects and behind, trying to get their own stuff done. So I know that's easy to say. When you actually get into the process, you're going to the schedule and everyone wants to see you mapping your percent completes and all that stuff as the project goes on. Natural tendency in technology projects is to gather low-hanging fruit first, right? To generate some momentum, give the appearance of progress to stakeholders. But we need to learn about the system. This is bad behavior. Tackling risks first gets the teams engaged on the priorities of the programs first. What you're saying to the program is, this is critical to our success. Managing risk, making sure these risks are taken care of early on, is key to our success. And you get the whole program on board when you move those to the left as much as possible. The longer those risks remain in the project, the more impact up and down the schedule the resulting scope changes are going to have, both in unit testing, system testing, and then back-end regression testing. So don't waste the days early on in the program. Remember, when you hit the risk later on in the program, you have some problem that pops up. What does everyone do? Everyone works overtime, everyone comes in, everyone has to sort of rally around the problem. But remember, a day on the last day of the project is just as long as a day on the first day of the project. They're both 24 hours. if you can move those risks and react to them earlier on, throw more people at it early on, and try to maintain your milestone schedule, those early milestones, then what have you done? You've basically handled these risks without killing the delivery time of the project and probably reducing a whole lot of headache, stress, and overtime work downstream of the project just by focusing early on and making sure we get the scope right and the design right and the testing right for those risks as much as possible. You can always throw more people at the work once you've figured out the hard stuff, right? Once you get those risks figured out and the rest of it's just straightforward execution because we've actually burned down all the risks, then it's a lot easier to get a lot of different people add developers in when you don't need your key technical minds all focused on a particular risk and solving that. So, summary of the whole set of presentations here. Remember, projects are complicated. Know the success factors when you're getting into it. Keep a watch on your risks. Take advantage of those inevitable changes as they happen to burn down some of your risks early on. If you have margin and you have opportunity to use it to burn down a risk. If a risk is out there, move it as far to the left as possible in the schedule so that you can address it early on when the costs of any changes to scope or costs of any changes to design are going to be as low as possible. Remember, the number one source of project delay is bad quality, resulting need for rework. If you realize a quality problem down the road, you have to go rework it. That rework is going to generate a bunch of other testing and other rework and adjacent programs. That is your number one source. So keep the quality as high as possible moving forward. Once you get something done, make sure it's done right, and then move on to the next thing. Eat your vegetables first. Shift risks to the left. Get your quality done. Spend the time up front to get it all right. It may seem like you're barely making schedule because you're spending so much time, but then down the road, you're not going to encounter these surprises. You're not going to encounter risks, and when you need to just burn through that last set of units and deliverables and such, now your learning curve kicks in, right? And you start actually going a little bit faster than you thought you would, then you're able to complete on time and on budget.